Okay, in this problem here, we're going to integrate by substitution, and depending on time, I'm going to try to squeeze in two problems for you here in this short video. The first one being, we want to integrate between 0 and pi over 2, 90 degrees, that's radians, right? Pi over 2 radians is 90 degrees, of this integrand with respect to x. A couple of things I want to recall that you should know going into this problem here. First of all, whenever you see this notation sine squared x, it really means the quantity sine x being squared. Right? It means sine x times sine x. Or for example, if you saw cosine cubed x, it really just means cosine x raised to the third power. So cosine x times itself 3 times. The other thing too that you should recall from trig days is that the sine of 0 is 0, and the sine of 90 degrees, or pi over 2 radians, is equal to 1. Okay, so with those things in mind, I can bring that back if I need to. Let's go ahead and tackle this integration here. The first thing I notice is I have a constant here of 3 that can come completely out of the integrand there, the integration. So I'm just going to move that 3 all the way out, okay, out front. We'll tackle that later. And the other thing too is, again, you can kind of see this as you go through enough of these integration problems. Let's let u equal sine x, not sine squared x, but just sine x. Okay? If u is equal to sine x, then I hope you see that du with respect to x, well, the derivative of this is just simply cosine x. And again, if you want to get that du all by itself, algebraically, you would multiply both sides by dx. Right? So du can be written as cosine x dx. So there, I just multiplied both sides by dx. Okay, so keep this in mind. Anywhere you see a cosine x dx, we're going to replace it with du. Hey, I see one right here, look. I see a cosine x dx. We can replace that with du. And everywhere we see a sine x, we can replace that with a u. Well, I see a sine x here, but this is really the quantity sine x squared. Okay, so we're going to write that as, remember, anytime I see this sine squared x, it's really just sine x squared. So I'm going to replace this thing here in the middle with just a u, which makes it now u squared. Okay, so let's rewrite our problem. Our problem now looks like this. I've got a 3 out front. I'm integrating between 0 and pi over 2 of u squared, right? Instead of sine squared x, we're going to replace it with a u, so this turns into u squared, and in place of cosine x dx, we're going to substitute that with du. There you go. Alright, this is a little bit more manageable now, and again, we'll handle the definite integral part of it a little bit later, but give me the antiderivative of u squared. Hey, that's u to the third over 3, right? Now this 3 that's still out front is still there, and it actually cancels out with this 3 on the bottom that came from that new exponent. So these guys cancel out, and I'm simply left with u to the third. Right? Now again, if this was an indefinite integral, I'd have a plus c sitting right here, but because it's a definite integral, I'm going to integrate between 0 and pi over 2 in just a second. But let's rewrite this thing, because I don't really want u to the third, I want it with respect to x. And since u is equal to sine x, I really have sine x to the third. Right, back substituting that u back in there. Okay, this is what I'm going to evaluate between 0 and pi over 2. So the fundamental theorem of calculus says to rewrite this thing here, right, to rewrite this as, here it goes, to rewrite this as sine, and everywhere I see an x, I'm going to put in a pi over 2, okay? And this whole quantity is raised to the third power, right, minus sine, and in this case, everywhere I see an x, I'm going to put in a 0, quantity raised to the third power. So that's what the fundamental, there you go, you can see that fundamental theorem of calculus says to do. Alright, well, the sine of 0 we just said a while ago, a moment ago, sine of 0 is just 0, so this whole term really just kind of wipes itself out. We don't really need that anymore. And the sine of pi over 2, well, that's just 1. And so I really have as my final answer 1 raised to the third power. Well, hey, that's still just a 1. So the total area, right, for this definite integral is simply just a 1. Okay, that problem wasn't so bad. Let's try another one. I think I have enough time to squeeze in one more. This one's going to be a little bit trickier. This one's going to be the integral, let's see if I can do this up here, right, between negative pi over 4 and 0 for 3 tangent of x secant squared x dx. Ooh, yeah, this is a good one here, okay? Let me go back to that recall sheet for just a second here. What is something else you should remember here, because this is going to be pretty important, okay? What is the tangent of pi over 4? In other words, it's a tangent of 45 degrees. Well, I hope you see that that comes out to be 1. All right, we're going to need that a little bit later on. Or its buddy here, its cousin, it's analogous here. What if I went in the opposite direction? Right, what if I went instead of positive 45 degrees, what if I went in the negative direction, negative 45 degrees? Well, you know that only cosine is positive in quadrant 4, so that would give me, if I'm using tangent of negative 45 degrees, that would give me a negative 1. Alright, so keep that thing in mind, right? Tangent of negative 45 degrees is negative 1. Alright, so back to our problem here then. What we're going to do is we're going to let u, equal tangent of x. And if you're wondering, how do I know which one to use? How do I know where to set u equal to? Well, try out different things. If you let u equal secant x, and you take the derivative of it, you see that it won't work, right? So give me the derivative of u now with respect to x. Hey, that's just secant squared x. And I do see a secant squared x, so that's how you know that you used the correct substitution here. If I multiply both sides by dx, I have du is equal to secant squared x dx. And I see one of those. Look, that's right there. Okay, so we're going to substitute that in place of du. We're going to substitute tan x, this thing here, with a u. And since that 3 is just a constant multiple, I can kick it all the way out front. Okay? Alright, so let me rewrite this now. Let's see, let's rewrite this thing. I have a 3 out front, the integral between negative pi over 4 to 0. And again, instead of tan x, I'm going to replace it with a u. And instead of secant squared x dx, I'm going to replace it with a du. Alright, let's see, let's keep going here. Now give me the antiderivative, that's just a 1 as an exponent, right? Give me the antiderivative of that. That's pretty simple. We're just going to add 1, my new exponent is 2, and that 2 moves to the denominator. So here's what we have. We have a 3, that's coming from here, u squared, that's coming from this numerator, all over 2. But wait, what was u? U was really a tan x, right? So this is really 3 tan x quantity squared all over 2. And we are going to determine or evaluate this between negative pi over 4 and 0. Alright, so let's wrap up this problem here. Here we go. Let's, using the fundamental theorem of calculus, let's rewrite this thing here. I have quantity 3 tangent, but instead of x, I'm going to put in a 0. Quantity squared all over 2, right? Minus 3 tangent, instead of x, this time I'm going to put in, instead of a 0, I'm going to put in a negative pi over 4, and that quantity was squared, right? The quantity is squared all over 2. Okay, that's looking pretty nasty, isn't it? But not to worry, because this is actually going to get simple on us in here in a second. Do you see that the tangent of 0 is simply just 0? So 0 squared times 3 divided by 2, well, who cares? All of this is just going to go away. Right? Now don't forget I have a negative still here. So let me rewrite this term for you. I have a negative, okay, this marker's dying on me. Alright, I have a negative 3 over 2, okay, there it is, times the tangent of negative pi over 4. We said a moment ago, right, remember the recall? We said a moment ago that the tangent of negative pi over 4 was a negative 1, right? So I can replace this right here, I can replace this right here with just a negative 1. But that negative 1 is being squared, which now comes back to being a positive 1. Right? And so my final answer is simply just a negative 3/2. Just a negative 3/2. And the negative, again, is coming from this minus sign that was in between my two quantities using the fundamental theorem of calculus. So there, substitution, integration by substitution, not a bad thing. Hope that helps.